Hello, we're going to be talking about the SuperTrol 2 setup program. This is a Windows-based program that can reside on your PC and can be used to communicate over the standard RS-232 port that is on each of the SuperTrol family members. Each setup disk is unique to that particular model series. In this case, we're going to be working on one for the SuperTrol 2 and ES749. When you launch the program, you'll see the following. You can start off by opening a template, and we're going to be selecting one for Steam Mass. You're going to have to navigate to the directory where the SuperTrol 2 setup program is located. This will be on your C drive under an area that is the FC2, and we're going to be opening one that says steammass_steammass.fc2. This will be easier if you're opening the program and the template at the same time. But we're going to start there. You'll have to select the COM port that matches where you have your USB to 232 cable using 9600 no parity. Now the file is loaded. You'll notice across the top that there's several tabs: File, Setup, View, and Miscellaneous. I normally start off by doing a Save As, and I'll give this a new file name. Let's just call it IDEA Demo. Now, any work that we have should be saved to that area. Now, when we go to the Setup tab is when things start becoming more interesting. You'll notice that there's, on the upper left, there's a flow equation. And if we select that now, it's going to be saying Steam Mass. And that's what we want, so we're going to click OK. You'll notice there's many other equations that can be solved. When we go to the display list, we can end up now selecting what items are going to be on the scroll display when the unit powers up. So we're going to use the slider bar and show mass flow and mass total as being our two default items, one on line 1, one on line 2. We can set the maximum decimal point to be a smaller value. Let's select 1. The up and down arrow keys can be used to enter that information. And I might start off with a display damping of 3. The totalizer rollover limit matters in some cases, since only up to about 7 digits can be displayed or accessed with a resolution over an RS-45 communications, but the default is 9. So we're going to click OK here and move to the next screen. The next screen is units of measure. Here we can select what we want to have for each of the active variables that are being shown. So with a time base of hours, which is common, we can go through now and we'll just look at them one by one. Mass flow will be represented in pounds per hour, mass total in pounds, volume flow in cubic feet per minute, per hour, volume total in cubic feet, and there's others. You'll have your pressure and temperature and density. Temperature in English units of measure, degrees F, pressure in PSIG, and density in pounds per cubic foot. So we're going to click OK, saying that those are the units we want to use. When we go to the flow input, this SuperTrol 2 family works with a wide variety of flow meter types. When we're looking at a vortex meter, we might consider that a linear meter. And if we want to deal with a pulse signal from it, we would select this digital 2.5. And here we could put in a low pass filter setting of 2000, which would be representative of the highest frequency likely from a vortex meter. And we could set a meter expansion coefficient of about 28.8, which is typical for stainless steel. And there's a place where you can enter the actual K factor in terms of pulses per cubic foot coming from the flow meter. So we're going to click OK at this point. We're going to go to the fluid selection. And we're going to be, in this case, working with a saturated steam. So that's already selected. And you'll notice there's a large number of variables that are grayed out when they're not active. So we're going to click OK here. Next, we're going to go to the compensation inputs. And we're only going to be using just pressure as a live variable. So we can select a temperature of not used. We would still put in that calibration temperature, which is what the basis was for the pulses per cubic foot that was declared earlier at the K factor. We'll click OK. Go to the compensation input 2. And here we're going to use a 4 to 20 milliamp gauge pressure transmitter of 0 to 250 psig. You'll notice in some cases you have to backspace over to enter a number. We're going to set the default pressure to 125 psig. This is the signal that will be used if there's ever a loss of the 4 to 20 milliamp signal coming from the pressure transmitter. Now we're going to select OK. Next, we're going to be going to the pulse output. And we're going to be trying to generate a pulse of 1 pound per pulse, an active pulse type following mass total. We're going to click OK. On the current output 1, we're going to retransmit now a mass flow rate signal. And we'll be, let's say, 0 to, let's say, 10,000 pounds per hour. The actual value will depend on the meter size that you have and your operating pressure. You can click OK at this point. And we'll leave current output 2 since it's not used alone. It'll have a default range in it. We're going to also go now to the relays. And here we can have alarm points if we want. You'll see the relays can be assigned to various process variables or totalizers, and there's various modes of operation. We're not going to be using those, so I'm just going to leave them right now at the defaults. And we're going to be now just going to the administrative page. And here we can define a password where it has private code that will be used to lock this instrument. So we can create like a new private code if we wished, other than the 1000. There's also some places in there where you can put in administrative information about the metering site if you wish. More of these are actually activated if you have entered like a password on the File tab. But for right now, we're just going to ignore that. Click OK. Next up on the list is for the printing and data logger functions that are built in. Here I can select a variety of items to be logged periodically. I can select time and date. And maybe pressure, since that's a variable that we were measuring. And it can be stored within the unit itself. If I choose the data logger only function down on the bottom, asking it to be in a database format that can later be uploaded, and I can set how often data logs are going to be made. So we're going to set this up on an interval, and we're going to make that interval 1 hour. This is in hours and minutes, the way it's defined there. And we're going to click OK here. Now we've done the basic configuration. Now at this point, we would go back to the File tab and save all these settings to that file we had created. At this point, there's several things we can do. One is if we wanted to create a paper record, we can hit the Print System Setup function. Some of these require 2 key depressions. And here we go. We see an output that can be created that can be sent to the printer. We can scroll down that and just observe all of the variables we had created. And we can save this as like a text document if we wish as well. I find this very useful if I want to send information to someone at a remote site who's asking for support questions. Now, the other thing we can do is we can download this information now into the instrument itself. So it'll go from the PC, downloaded into the instrument. This process takes several minutes, but you'll actually watch the transactions as they're going. We can now close this. And this lets us now demonstrate the View tab. When you click on the View tab, it allows you to view the information that's being computed by the flow computer and showing it in this open form. So you can do things like select the process parameters, the signal inputs, which are all the multimeter functions that it has, as well as looking at items like the analog output, like what's being sent to other pieces of equipment. Once we start this, it's going to be gathering information from the instrument. Now, in this case, we don't have simulators on all the flow inputs, so a number of these variables are going to be just reading 0. But it gives you an idea of the values that are available. And you can kind of tell from the time clock advancing periodically that it's updating information as we go. So the View tab is kind of a fun feature during startups when you still have your PC connected to the instrument itself. So you have to stop the View tab before moving elsewhere. If we go to the Miscellaneous tab for a minute, you'll notice that there are certain functions that are available for it. The number of these vary depending on whether you're in a supervisor mode or just an operator mode doing a basic configuration. Certain ones that to point out is the network card setup, where if your unit has a Modbus option card put in it, this is where your settings are changed. These are the way they go from the factory with those settings. Other things are a list of which options were supplied by the factory. In this case, the stacking option, the NX19, the peak demand were all provided with the instrument. The ones that are listed as disabled are not actually equipped, but it allows you, if you're not connected to an instrument, to create a setup for that instrument as if it were actually equipped. These will not enable features. They're just to allow the setup program to simulate those functions. Now, if we go to the File tab for a moment, I can show some of the administration functions. On the login, if you go in with a 2000 level password, that'll gives you a supervisor access. When we go back to the miscellaneous tab now, you'll notice that there's more of the boxes are enabled. So now you can do things like remotely reset totalizers, create sign-on messages, as well as other features. One that's of interest is the one called simulation. Here you can take control of the instrument and actually ask it to generate some outputs. This is helpful when you're doing a startup where there aren't actually flow meters connected yet, but you want to be able to drive these signals into a PLC or other remote SCADA system. So if I select frequency as what I'm trying to simulate, and let's suppose I want 1 hertz as the signal to be generated, and I hit start, it'll start doing a pulse output every 1 second. It allows you to verify the equipment that it's connected to is actually receiving the correct signal. Similarly, I can go to the current output 1, do a simulation of it. Let's say at 12 mils, for example. And at the same time, I can do more than one. I can have the frequency, the currents, all doing simulations at the same time. Now, in order to leave this page, it will require you to stop these. So if we hit close, you'll notice that it'll start turning the items off one by one before actually closing the form. This prevents you from leaving the SuperTrol flow computer itself in a mode where it's generating simulated signals rather than real signals. So we're going to go back to the File tab one more time and do a save, just since we've been working for a while. And that kind of completes the sequence that I would use in configuring instruments. I find it very helpful to send both a setup file itself, like in this case, it was IDA space demo, as well as a printed text document, both to keep in the file and to send to customers if they're needing support remotely. Thank you very much. This has been the SuperTrol 2 setup program.